Looking into someone's eyes can tell us so much about them. Neuroscientists give us some secret insight as to what our eyes may say about us. Tune in to find out what they say, only here on the Pupil Scientist podcast. You are listening to the Pupil Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Guess who's back? Back again. Stephanie's back. Hello, my Pupil Scientist Army, and welcome back to the Pupil Scientist podcast for episode 106, where every week I arm us with some scientific information so that we can all be a little bit smarter and healthier every week. I had a nice break. I took Memorial Day to Independence Day off as a little holiday from the podcast. And during that time, I got to lots of brainstorming and thinking about new topics that I'd like to cover for all of us. I have covered 105 topics so far, which is pretty exciting. Everything from the scientific information on sunscreen, to plant-based diets, to the neuroscience of jealousy, to how we can use neuroscience to help us reach our goals, and how we can use neuroscience to fight food cravings, and so much more. So if you haven't given some of those previous episodes a listen, take a scroll through and see if anything tickles your fancy. So for episode 106, what are we going to cover today? Well, I came across an article published last month in the journal Cognition that details how the characteristics of our eyes, or more specifically our pupils that are in the center of our eye, how that may give us insight into our intelligence. Is it possible that we can look into someone's eyes and determine how intelligent they may be? Let's dig into those scientific details to find out. And as we always do, let's start off first with some core takeaways. Some would argue that our eyes are our greatest communication tool because of the efficiency to which the eyes can indicate a feeling or emotion. A quick glance or an expression can say so much. Eye contact with a partner can convey our emotional and mental state. When we make eye contact with someone, our brain regions involved in mirroring or mimicking are likely to be activated. It is thought that eye contact induces empathy and mimicry of the other, and this unspoken communication of emotional state can go back and forth between people without saying a word. Extended eye contact may induce changes to heart rate, breathing rate, and skin conductance. Beyond nonverbal communication, what else can our eyes say about us? Well, some scientists measured the dark inner circle of our eye called the pupil. The size of the pupil can change with arousal, focusing upon a task requiring mental effort and attention. And scientists even noted across a few different clinical trials that under resting conditions, the larger someone's pupil, the higher their intelligence. And that was an association, but an intriguing association, isn't it? So our eyes might be able to say so much about us, can't they? Now, let's get into those details. The eyes are philosophically thought to be a window into the soul, and they just might, as they can tell a lot about a person. Everything from our emotions, our mental state, if we are attentive, and yes, maybe even certain aspects of intelligence. In fact, Mazur wrote in the American Journal of Physiology that eye contact, or gazing into someone else's eyes, holds a lot of power For example, it can convey dominance over someone, like in a stare down. It can be a communication channel unto itself by using non-verbal cues to send a message to someone else. In clinical trials, scientists noted that gazing into the eyes of someone can elicit a physiological response of increased skin conductance, dilated pupils, and changes in breathing rate and heart rate. In the journal eNeuro in 2019, participants were told to maintain eye contact with their partner and simultaneously underwent fMRI scanning of their brain to understand which brain regions were involved in this task of eye contact. The scientists noted that their response to eye contact was regulated by their cerebellum and the limbic mirroring system of their brain. So they found a really cool finding that eye contact almost speaks to our desire to mimic or mirror someone. It could be a tool to induce empathy. Eye contact is a way in which we can share our emotional and mental state with someone in a non-verbal way. The other individual may mimic or empathize with that emotion being conveyed, and this seems to be regulated by brain regions responsible for mirroring. So, for example, you can look into someone's eyes and convey that you love them by just looking at them. They may mirror that emotion and convey with their eyes that they love you too. Perhaps now the message changes to something else, and it can go back and forth between two people with just a look or a gaze, with each person mirroring the other. So nonverbal communication and mirroring with just our eyes. Cool, isn't it? So if our eyes can be tools for communication, what else can they say about us? Well, a particular part of our eye may actually say a lot. When you look at someone's eyes, when you see the color part of the eye, whether that be brown, gray, blue, hazel, etc., that is called the iris. Now, how about the dark circle in the center of the eye? That is the pupil. Now, the pupil is the transparent opening to the center of the eye. The pupil is where light enters into our eye. It appears dark because it is literally the window into the center of the eye. It is not opaque and black, but rather a look deep into the inner part of someone's eye, which is dark, so that is why it appears black. The pupil appears to become smaller or larger under different circumstances. And what determines these changes in pupil size is really intriguing, and some people have dedicated their entire scientific careers to understand what causes our pupils to change size. What does it tell us when our pupils change size, or at baseline if they're smaller or larger versus someone else? Well, through the work of many scientists, we realize that when our pupil, that dark circle in the middle of our eye, changes size, it may tell us a lot. For example, the pupil becomes smaller in response to brightness. It does this so that less light enters into our eye. Our pupil may also become smaller when we fixate on something in front of us. Now, the opposite, our pupils may dilate in response to being aroused, when we increase our mental effort, or because we are in the dark to allow more light in. Now, I think most of us could have guessed that the pupils become smaller in bright light and larger in the dark, and this is to regulate the amount of light entering the eye, like the aperture of a camera. But the idea that our pupils may dilate due to arousal might be new information to many of us. For example, Hess and Polt, all the way back in 1960, had participants look at images that were identified as arousing to them. Now, the results were pretty clear. When participants viewed arousing images, their pupils dilated significantly or became larger. For example, men's pupils became larger mostly to images of naked women, whereas women's pupils became larger or dilated to images of babies or to images of naked men. Pupil size also correlated with other physiological measures of arousal like skin conductance, or our hair standing on end, or feeling a tingling sensation on our skin. So if you notice someone's pupils dilate, it may mean a few things, and it could mean that they like what they see in front of them. What else might impact our pupil size? Well, certain addictive drugs like cocaine, ketamine, or LSD or benzodiazepines can cause the pupils to become larger as well. Drugs like opioids, including heroin, oxycodone, and fentanyl, may cause the pupils to become smaller. This is a phenomenon called pinpoint pupils because the pupils become so small. What else might our pupil size say about us? Well, it may also provide some insight into someone's intelligence. Back in the 1960s, it was realized that the size of our pupils, that dark circle in the center, may reflect our mental processing of information. For example, the size of participants' pupils can track their effort when memorizing things during a task. The pupils tend to become larger when trying to memorize something, and they become smaller or constrict when trying to recall that memory later. So pupil size may also be an indicator of mental effort in real time. Back in 2016, Tukakara and colleagues published in the journal Cognitive Psychology one of the first clinical trials to indicate an association of pupil size to intelligence. The scientists recruited 40 young adults aged 18 to 35 years old. Half of the participants were identified as having above average working memory, meaning a high ability to memorize things on the go. The other half of the young study participants had below average working memory, meaning difficulty memorizing things quickly. The scientists measured the participants' pupil size at baseline under controlled light settings. They noted that the individuals with higher working memory had larger pupils, in fact 1 millimeter larger, which is a difference large enough that we could see that with the naked eye. Our pupils are only about 2 to 4 millimeters wide in bright light. So considering that those with above average working memory had 1 millimeter wider pupils is quite a percentage bigger, about 25 to 50% bigger. The scientists repeated these measures across several weeks in the individuals, and the same differences in pupil size were noted. Now, during a memorization task, the pupils tended to dilate about 0.25 millimeters, which was similar in both the groups. So it appears the baseline size of pupils might differ in those with a better ability to memorize things on the go. Next, the scientists looked at something called fluid intelligence. Now, fluid intelligence is a very cool readout, and it is a great skill to have. Essentially, it is the ability to reason, to take in new information and be able to understand it, to transform that information, to create new information from that, and to do so in rather quick timing. So again, that is called fluid intelligence. For this study, the scientists recruited more young adults, about 110 individuals. Again, about half the participants were above average for working memory, and the other half defined as having low or below average working memory. Again, the scientists noted a larger pupil size in individuals with better memory. But intriguingly, during the fluid intelligence test, where the participants had to use their skills of reasoning and information processing, those with better memory had a reduction in their pupil size during the task, whereas those with poorer working memory had basically no change in pupil size. The scientists also controlled for mental effort and saw no difference in mental effort between the groups. So it is intriguing that, through several studies, the scientists showed a correlation between some measures of intelligence and cognition with pupil size, and the dynamics of their pupils as well. So individuals with higher measures of working memory and fluid intelligence tended to have larger pupils at baseline and more changes to their pupil size when they focused on the task. So why is pupil size related to certain measures of arousal, attention, addictive drug intake, memory, and intelligence? Well, pupil size seems to be influenced by a brain region called the locus coeruleus. This is located in the upper brainstem and has very long connections to the rest of the brain. This brain region releases the neurotransmitter and hormone called norepinephrine, which is one of those quote-unquote fight or flight response hormones. Now, norepinephrine is known to regulate our level of attention, learning, and memory. So the scientists hypothesize that in individuals who have larger pupils at rest, that they have greater regulation of their locus coeruleus, which benefits their intelligence and attention span. The fact that the pupils of our eyes may provide information about our locus coeruleus of our brain and our ability to be attentive is also shown in clinical trials, including participants with attention deficit hyperactivity disorder, or ADHD. Now, in individuals with ADHD, they may have difficulty focusing, concentrating, and remaining attentive on tasks. In the journal Scientific Reports in 2017, the scientists noted that the pupil size was smaller in participants with ADHD versus control subjects without ADHD. When the participants were put on medications to help manage their ADHD, their pupil size became wider and more similar to the control subjects. It's a pretty cool finding, isn't it? So, in another clinical trial, they illustrate that pupil size is likely to give insight into someone's attention span and mental state. So there you have it, my pupil scientist army, a look into our eyes. Our eyes can say so much about ourselves. They can be a powerful tool of communication that can bring about empathy and mirroring in other individuals. They are a way of us saying our emotional and mental state without using words. The characteristics of our eyes, particularly the size and changes of our pupil, can give an insight into if someone is experiencing arousal, if they are attentive, have high mental effort, and may even give insight into someone's level of intelligence and working memory. As there were repeated associations of larger pupil size with higher levels of intelligence. Smaller pupil size is observed in individuals with a reduced ability for attention, such as in individuals with ADHD, which seems to be rescued when they are provided medications to help control or increase their attention span. So I hope that this episode was intriguing for all of you. I know that I learned a couple new things in this episode and found it really neat. Now make sure to follow me on social media where you can see some of the studies that I cite in each episode. I hope that you all have an awesome week, and I'm looking forward to meeting you all back here for episode 107, the same time and same place next week on the People Scientist Podcast. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.